Right, so I hope everybody did a good job adding and subtracting fractions with like denominators. So now we want to move on to adding and subtracting fractions with unlike denominators, which is usually where it gets a little bit tricky because again we're trying to use trying to find common denominators and things like that, which can cause us some trouble. So the first thing we want to look at here is we want to use an area model to add 1 1/6 plus 3/4. So now the problem is we can't do like we did last time and just dive in right away and start dividing our model up because we don't actually have the same denominator in this case. So if I break it into sixths or if I break it into fourths, it isn't necessarily going to help because I won't necessarily be able to graph these. So the goal is we need to come up with some kind of a common denominator, common thing that we can use to break these guys up. So I would usually have you guys use fraction towers to actually figure out what the common piece was. And so I do have a one that's online, but unfortunately it doesn't go up high enough for what I need. So I need to go up to 12, but it doesn't actually go up that far, which is kind of unfortunate. But you could still get at least the idea of what it would look like to add, whoops, I think it's 1/6, isn't it? 1/6 and 3/4. Let's see. So 1/6 plus 3/4. So you could actually just go through and drag, like here's 1/6, and then if I wanted to add 3/4 to it, I could do this. So I can tell the big rectangle means it's 1, so it's something less than 1. And then in a perfect world, if I had the 1/12 here, which would be the common denominator, I could lay these guys down and it would show me exactly what it adds to. Unfortunately, there's no 1/12, which is kind of unfortunate. You could get a similar idea by laying a bunch of sixes down if you imagine those 1/6 being broken up into halves. But so unfortunately, we can't use this to kind of help us with this. But that would be the idea of how you would actually do this using fraction strips and stuff. And it can work for ones that we have the denominators for. It's just unfortunate 12 doesn't work. But all right, so in this case, so we've decided that our common denominator is going to be 12. So first thing we're going to do is rewrite each of these guys in an equivalent fraction by making them have a denominator of 12. So the goal is we know what's going to go on the bottom. So we just need to figure out what to do to the top to make it so that it stays balanced. So in this case, to go from 6 to 12, we had to multiply 6 times 2. So that means I have to multiply the top times 2. So 1 times 2 is going to give me a 2. Same thing with 3/4. To go from 4 to 12, I had to multiply by 3. So that means I need to multiply the top by 3. So then that gives me 9/12. And so now that I've got our common denominator, now we can divide this rectangle up into those 12 chunks in this case. So I need 11 lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So again, in the perfect world, they should all be the same size, which mine aren't even close, but that's okay. And so now what we want to do is, now that they're the same and we have the common denominator, now it's exactly like we did in the first part. So we just want to shade the different sections. So in this case, we want to shade 1/6, but we want to shade what 1/6 is equal to, which is 2/12. So in this case, we're going to shade 2 of these rectangles. And so this is our 1, 2. So this gives us our 1/6 or 2/12. And so now we want to shade 3/4 more, but again, we have to shade it in terms of our common denominator. So that means we need to shade 9/12. So let's do it and say purple. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So shade all this guy in. And so again, we add these up, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's our 9 representing our 3/4. So finally, what fraction is shaded? So let's add up underneath. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we've got 11 chunks that are shaded. out of 12 total. So in this case, 1/6 plus 3/4 would be the same thing as 11 over 12 in this case. So again, once you get the common denominator, it's exactly like we did in the last section. So that's really the only difference between what we did first and what we're going to do now. All right, so let's take a look at a number line here. So again, same idea. We're trying to add 1 3/4 and 7/8, but unfortunately they don't have the same denominator, so we can't jump in right away and try to figure out how to actually combine these guys together. So in this case, so this one a fraction tower would actually work good on. So let's look at what 1 3/4 and 7/8 would look like in this case. Let's clear this out. So 1 3/4, we could bring just a whole 1, and then 3/4 over. And then to that we were adding, what, 7/8, I think? Is that what it was? 7/8, good. There we go. So in this case we'd get 2, 3, 4, 5, 6, 7, 8. And so now we could start trying to figure out exactly what's going on with these, how we'd get a common denominator and stuff like that. So in this case, like, the nice thing is it looks like 1/8 would actually be the nice common denominator for these guys. So if you were trying to figure out the answer, you could actually just pull over all of these things like that, because these are all just 2's, and then just copy our number of 1/8 underneath. And so by using fraction strips, it looks like our answer would be 2 and 1, 2, 3, 4, 5, 6. 6/8 in this case, which we could reduce down to 2 and 3/4. So let's see if we get the same thing kind of using the number line. So again, this is kind of a way we can use those fraction strips or fraction towers to go along with the number line stuff. So let's go back here. So it looks like our common denominator is going to equal 8. And so again, now I can start to plot points and stuff. So in this case, it's 0, 2, and 3. And then again, since our denominator that we came up with is 8, then I want to break each of these big numbers up into chunks of 8. So I need 7 lines. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oops, 7. 1, 2, 3, 4, 5, 6, 7. All right. And so again, first thing we want to do is we want to plot 1 3/4 on the number line. But before we can plot it, we need to rewrite it so that it actually is in terms of the right denominator in this case. So in this case, we don't have to worry about the 1. The 1's just going to come along for the ride. The only thing we have to worry about is the fraction part. And I know I want the denominator to be an 8. So to go from 4 to 8, I had to multiply by 2. So to get the top number, I'm going to have to multiply 3 times 2 to give me 6 in this case. So 1 6/8 is the same thing as 1 3/4. So to figure out where that is on the number line, we just start with 1 and then count over 6 tick marks. So 1, 2, 3, 4, 5, 6. So that means we want to land right there. So that's our 1 3/4 or 1 6/8, however you want to think about it. And then to that, what we're going to do is we're going to add 7/8. Well, the nice thing is 7/8 is already in the right form. It's already the right denominator. So starting here, all we have to do is just count 7 more tick marks. Again, we don't have to worry about the denominator because we did that when we did the chunking. So now we just need to worry about the top number. So 1, 2, 3, 4, 5, 6, 7. So that's going to land us there. So this is 7/8. So finally, the answer is going to be this big stretch here. So this is 1 3/4 plus 7/8. And so where did we end up landing? So we know we're at 2 something. So now we'll just count every tick marks to figure out our top number. So 1/8, 2/8, 3/8, 4/8, 5/8. Oh, did I do that right? Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Nope, I feel like I've got too many lines or something. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 6, 7, 8. All right, let's look here. So let's see. So I've got 2 and 1, 2, 3, 4, 5. 2 and 5/8. Is that what we had before? Maybe I miscounted on the last page. Let's check what I. 1, 2, 3, 4, 5, 6. Oh, because I'd added 8/8. All right, so that was my bad. We shouldn't have had these. These shouldn't have been here. So I put too many eighths out to begin with. All right, so this is making sense now. So this is 2 and 5/8 instead. Sorry. So apparently you should do it right the first time. All right, so with that in mind, we get 2 and 5/8. So what is our answer as a simplified mixed number? It looks like 2 and 5/8 in that case. All right, so now let's do the same thing with subtraction here. So again, use an area model to subtract 3/4 minus 1/3 in this case. So again, what we can do is we can kind of look at these with the fraction towers if we want, turn them into the common denominators that we would need to. So 3/4 and 1/3. So let's clear this out since I messed it up anyway. So 3/4 would look like this. And then 1/3, what we're trying to do is we're basically trying to remove 1/3 from that. So the idea is, if I were to kind of, like what we're going to do mathematically is really remove this part. And whatever this is left over, that's going to be our answer in this case. But again, the problem is, how do I know what that is? I mean, I can see it graphically, but how do I know how to divide them up and stuff like that? So again, unfortunately, we would need the 1/12 strips to actually do this, and I don't have the 1/12 strips, but at least we can kind of visualize what's going on. So in this case, if we go back, again, just like before, our common denominator for this one's going to be 12. I don't know why I wrote that there. I should have just wrote it there, but so again, what we want to do is rewrite these as equivalent fractions. So again, we're going to get 12s on the bottom. And to go from 4 to 12, we're going to multiply this by 3, which means we need to multiply the top by 3. To go from 3 to 12, we want to multiply that by 4. So that means multiply the top by 4. So now we've got our common fractions. So at this point, we can go through, divide our area model up into the proper pieces. So in this case, we need it to be in 12 chunks. So again, we need 11 lines. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. And again, they should be all about the same, even though mine aren't, but that's okay. And so now that we've got it like this, it's exactly like we did in the first part. So we want to first shade 3/4, which in this case is going to look like 9/12. So we want to shade 9 of these rectangles. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so again, if you want, you can go in and write down just to verify that we've got the right amount. And then now we want to use the takeaway method, and we want to take away the 1/3. So same as I did before, but now we want to take it away in the right size block so we actually know what our answer would be. So in this case, 1/3 is the same as 4/12. So that means we want to scratch out 4/12 or 4 of the blocks. So we want to get rid of 1, 2, 3, and 4. And so how many are left over once we cross those out? We've got 1, 2, 3, 4, 5 chunks. So that's going to be our top number divided by the way we divided it up, which was 12. So 3/4 minus 1/3 would be the same thing as 5/12 in this case. All right. So finally, moving on to subtracting with number lines. So again, this is the same idea, same way we did before. So again, first thing we'd have to do is get a common denominator. So this one would probably actually wouldn't look as bad on the fraction strips just because 8 and 4 are almost the common denominator. So if we did 1 5/8 minus 1/4, this one actually wouldn't look too bad. So we might as well do it so we can get an idea of what's going on. So 1 5/8. So let me make sure I actually bring out the right number this time instead of too many like I did last time. So there's 1 5/8 minus 1/4. And so I'm going to put it here rather than over with the 1 just because there's nothing broken up with the 1. So I'm going to put it here with these guys. Like right under, whoops, well, let me put it where I want. There we go. Like that. And so again, the idea is with these, I'm going to be able to just kind of scratch out that part. And in this case, since 8 and 4, like 8's the common denominator, the 4 matches up perfectly, so it makes it a little bit easier. So I can see that I've got a 1 left over and then 3 1/8 pieces. So it looks like, based on my fraction strips and assuming that I actually put the right number out, our answer should be 1 3/8 with this number line. But let's go back and check just to verify. So in this case, so again, first thing we need to do, common denominator. And again, in this case, it looks like 8 would be the perfect one. So again, first thing we want to do is we want to divide this number line up into whole numbers first and then into a bunch of 1/8 chunks. So in this case, since we're doing subtraction and I like to give myself some room, I'm just going to do 0, 1, and 2 to use as much of the line as possible. So now let's divide this up into 1/8 chunks. So we need 7 lines. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And so again, first thing we want to do is we want to plot 1 5/8. Now in this case, we don't have to do anything because 8's already the common denominator, so we can go ahead and plot this right away. So again, starting at 1, we just want to count over 5 tick marks. So 1, 2, 3, 4, 5. So this is where we're going to land. Oops, almost overshot it. for 1 5/8 in this case. Oh, well, now I got to draw it again, so maybe I'll do a better job this time anyway. So there's our 1 5/8. And so again, depending on how you want to think of this, is either a subtraction or a missing add end. As a missing add end, again, we would say what number plus 1/4 equals 1 5/8. So again, we kind of start with 0 and try to figure out what that would be. So in this case, even before we can do that, we can't do anything with this 1/4 until we convert it into a common denominator. So the first thing we need to do is convert this into something over 8. And so again, to go from 4 to 8, I had to multiply times 2. So that means I want to do the same thing here, multiply the 1 times 2 and give me a 2. So in this case, 1/4 is the same thing as 2 over 8. And so now I can kind of go backwards and figure out, let me erase that because it's right in my way, how far to go back. So in this case, I want to drop back 2 places. So from here to here is my 2/8 or 1/4, however you want to think about it. And then from there, what would I need to add to that 1/4 or 2/8 to get the right answer? Well, I definitely have the whole number 1, and then 1, 2, 3 tick marks in this case. So it looks like 1 3/8 is what I'd have to add in order to get to 2/8 in order to get 1 5/8. And I think that matches up with what we did with the fraction strips, which is perfect. All right, so finally, 1 5/8 minus 1/4 is the same thing as 1 3/8. So perfect. All right. So the rest of them, again, so here's some practice story problems, just like we had before with unlike denominators. So again, one's a real story problem, one isn't. So try to figure out which one's real and why the other one isn't. And then there's a bunch of practice problems with unlike denominators. And then at the very end, there's just some, big old, just lots of different ones. So those, you can use the model if you want, or if you just want to use straight addition and subtraction rules, it's fine too. So if you have any questions or anything like that, just let me know. I'll be around all day. So good luck. Have fun.